Hi Gloucester students, I'm going to do a video today on how to solve an algebra problem when you have variables on both sides. And when I say variables on both sides, I mean letters on both sides. So here I have an X on the left side and X on the right side. So I want you to remember that this is like if we were doing graphing, this is like the initial value is -7 and it's jumping 3 each time. And here the initial value is 5 and it's jumping 6 each time. When you're doing algebra, you want things that are similar together. So we want, for example, our two rates of change to be together on one side. We want our initial values to be together on the other side. So what I like to do is I like to put X here and numbers here, or rate of change here and initial value on the other side. So what I want is I want all the rates of change part to be on the left-hand side. It doesn't matter which side you pick, but I'm going to just pick the left-hand side today. So I look at the 3x and I look at the -7 and I realize that the 3x is the rate of change part. So that's the part that I am going to keep. And then I look over there at the other side and I look for the other rate of change on the other side of the equation. I want this 6x to come and join the 3x, which is the other rate of change. If I want to move this plus 6x, then underneath it, I need to write down minus 6x. And that means over here, I need to have minus 6x. And then these two cancel out. Now, on this side over here, what initial value number do I have? Already, I have the 5. And the part I need to move with it was this -7 from the other side. So this -7 is an initial value, so it should go over here with the 5. But if I want to get rid of this -7, then I need to put a +7 here. And so then over here I have +7, and this cancels out. So what I have is I have 3x minus 6x. So that's going to give me -3x. Is equal to 5 plus 7 gives me 12. And then I have, I need to divide by -3. 12 divided by -3. My x is equal to -4. That's when they are the same. What I'm going to do is I'm going to make two table of values for these two equations just to check to make sure that that's actually true. I'm trying to write with one hand and not hold the paper. X, Y. So this one over here, it started at -7 and it kept jumping by 3 each time. So at 1 it would be -4, at 2 it would be -1, at 3 it would be 2. And the other one, my page is moving again. My page is moving. X, Y, it starts at 5 and it jumps by 6 each time. So 1 is going to be 11, 2 is going to be 17, 3 is going to be 23. Now, why did I leave this space up here? Well, because they're supposed to be the same when x is equal to -4. So I'm going to go backwards. -1, -2, -3, -4. -1, -2, -3, -4, and they should be the same up here at -4. So I need to just use my jumping number but go backwards. Instead of adding 3 when I go backwards, I'm going to subtract 3. So that's going to be -10, -13, -16, -19. Hopefully, when I do the same thing on this side, I'm going to get a -19 over here as well. So 5 minus 6 is -1. -6 again is -7. -6 again is -13. -6 again is -19. So yes, they are the same at -4, -19. And all I did was I took my rate of change numbers, my 3x, that was the part that was already a rate of change, and then I took the 6x, the other rate of change from the other side, and moved it after the 3x. And because it was a +6x here, it became a -6x here. Then on this side, I looked for the initial value that was already there. The initial value that was already there was the 5, so I write it down first. And then I look for the rate of the initial value on the other side, which was -7. I move it over to the other side, so it becomes +7. And then I just continue with regular algebra. So hopefully that's going to help you solve some questions today where you have variables or x's on both sides.